Hello everyone, this is Teacher Mama Ninil and welcome to Teacher Mama Diaries. If you're new to this channel, please consider subscribing. In this video, we will learn finding the GCF or the greatest common factor using continuous division or the ladder method. So what is GCF or the greatest common factor? GCF is the largest number, which is the factor of two or more numbers. Now, please look at this to help you understand more what GCF is. We have here the number 4. Let's identify the factors of 4. So 4 is equal to 1 times 4 and 2 times 2. So 1, 4, and 2 are the factors of 4. Now let us have another number, which is 8. 8 is equal to 1 times 8 and 2 times 4. So 1, 8, 2, and 4 are the factors of 8. Now 4 and 8 have common factors or the same factors. Their common factors are 1, 2, and 4. So the common factors of 4 and 8 are 1, 2, and 4. Now of these three factors, there is only one which is the largest or the greatest, and that is 4. And that is what we call the GCF or the greatest common factor. So why do we need to learn the skill of finding the GCF? GCF helps us simplify fractions easily. We can also use it in solving math problems that we may encounter in our daily lives. Now, in finding the GCF using continuous division, remember, use a common prime factor to divide all the numbers without a remainder. Or in other words, all the numbers must be divisible by a common prime factor without a remainder. Before we start with our first example, please take note of these 5 prime numbers because they are commonly used in this method, like 2, 3, 5, 7, and 11. So now let's begin with our first example. Let's start with finding the GCF of two numbers. Find the GCF of 8 and 12. First, let's make an L shape and then we arrange the given numbers 8 and 12 horizontally. Then what prime number can divide all the numbers? Remember, we can continue if all the numbers can be divided by a common prime number. So let's see from these prime numbers if any of them can divide both 8 and 12. So 2 can divide both 8 and 12 without a remainder. So let's write 2 on the side as the divisor. And let's make another L shape for the answers. Now let's proceed with division. 8 divided by 2 equals 4. Then 12 divided by 2 equals 6. Now the remaining numbers are 4 and 6. Let's see if we can continue dividing. What prime number can divide all the numbers? Let's see from these prime numbers if any of them can divide all the remaining numbers, 4 and 6. Again, 2 can divide all the remaining numbers. So let's write 2 on the side as the divisor. Then let's make another L shape for the answers. Now let's proceed with division. 4 divided by 2 equals 2. And 6 divided by 2 equals 3. The remaining numbers are 2 and 3. So let us see again if the remaining numbers can still be divided by a common prime number. So what prime number can divide all the remaining numbers? Let's see again from these prime numbers if any of them can divide both 4 and 3 without a remainder. And no prime number can now divide both 2 and 3. So this means we will now stop dividing or the process ends here. Next to do is to take the numbers on the side and we will multiply them. So 2 times 2 equals 4. So the GCF of 8 and 12 is 4. Now let us get the GCF of three numbers. Find the GCF of 12, 18, and 30. First, let's make an L shape and then we arrange the given numbers 12, 18, and 30 horizontally. What prime number can divide all the numbers? Remember again, we can only go on or continue with the process only if all the numbers can be divided by a common prime factor or number without a remainder. So let's see from these prime numbers again if any of them can divide all the numbers 12, 18, and 30. 2 and 3 can divide all the numbers, so we can choose either 2 or 3 as our divisor. Let us just choose 2. But don't be confused because we can also use 3. Either of them will still lead us to the correct answer. Now let's make another L shape for the answers. And we can proceed with division now. So 12 divided by 2 equals 6. 18 divided by 2 equals 9. 30 divided by 2 equals 15. Now, the remaining numbers are 6, 9, and 15. So we will find out again if these numbers can be divided by a common prime number. So what prime number can divide all the numbers? Remember again, we can only continue with the process if all of the numbers can be divided exactly or without a remainder by a common prime factor or number. So let's see again from these 5 prime factors if any of them can divide all the remaining numbers. So 3 can divide exactly 6, 9, and 15. So we will use it as our divisor. Then let's make another L shape for the answers. Now let's continue with division. 6 divided by 3 equals 2. 9 divided by 3 equals 3. 15 divided by 3 equals 5. The remaining numbers now are 2, 3, and 5. Now, what prime number can divide all of the remaining numbers? Let us see again from these 5 prime numbers if any of them can divide 2, 3, and 5 without a remainder. And no, we don't have any prime number that can divide the 3 remaining numbers. So this means we will now stop dividing. Next to do is to take the numbers on the side and we will multiply them. So 2 times 3 equals 6. So the GCF of 12, 18, and 30 is 6. So don't forget, in finding the GCF using continuous division, use a common prime factor to divide all the numbers without a remainder. And now, try answering this and comment down your answer. Clue: use the math skill taught in this video. Aya is packing goodie bags for her birthday. She has 24 lollipops, 36 candies, and 60 chocolates. What is the largest number of goodie bags can she pack without any goodie left? If you find this video helpful, please don't forget to give it a thumbs up. Goodbye!